Okay, let's make a new project, maybe a RF test, and we CDR test. Okay, CDRF test. Okay, and we create a new virtual environment with V and V. It'll take some time. Okay, here we go. And then we activate the virtual environment, and we are gonna use serial port, right? The serial port. The serial port will need to import a serial library, and we need to pip install pi serial, and it's gonna install the serial port library for us. And this is gonna be the only library we need to install for this project. And then we will use Python 3. Okay, I'm gonna show you how to do this from the command line. Okay, this is not clear. Oh, I'm not sure how to do the clear from a Python console, but whatever. Let me just tell you how this works. Okay, so I'm gonna import the serial port library, import serial, and then I'm gonna open the port and assign a port like ser1 equal serial and then this is the port name on the Chipsee all-in-one Raspberry Pi computer is TTY0, and then we will need to use the baud rate. The baud rate of this module is 9600, and that's all we gonna need from the very simple demo. And then we can because this demo sends 8 bytes each time, we will need to read 8 bytes. So we can just for test result equals ser1 read 8 bytes, and then it will start listening. And if I click to remote, like here, you hear that and you see that this one has exited from listening. We can see the result here is these bytes, and this is not very easy to understand. We can write the hex format. That's FD, F4, and it ends with a DF. So this is the signal that our module receives, and if we replay this signal, it will be able to copy and replicate the signal this remote sends. So how do we let this module send this string signal? Let me show you. The signal will be first. Oh, okay. Let me use a very simple way to assign this to a string. Maybe you maybe want to assign a string when you call this program in the future, when you use your own your own remote, or maybe some other kind of radio frequency equipment, like signal 1 equal this string. Well, it's a string now, right? And then we will be able to turn it to hex format, and we will be turned it to a byte format. You can see this one, byte signal equal bytes from hex, and then we will put the signal 1. Okay, you can see this byte signal will be exactly the same as the one we've got before, the one we got from the ser1.read, right? This is the byte signal. And then the most easy part is we will use ser1.write and this byte signal here. Well, nothing happens. Well, it has to be this dumb alarm. Let's try again. Nope. Nope. Oh, you hear that? Yeah, that says we are correctly controlling this alarm. You hear that? Right. And this will set alarm of this. Well, I think this alarm is dumb alarm, and we can try again and learn the disalarm button. Well, the alarm button, set alarm button. Okay, ser1.read 8. It's already, you know, this module maybe has a cache, so we can flush the cache first. Okay, and then we will read the 8 bytes. Oops. Okay. Let's see when we can right here we can exhaust the cache. Okay, let's use this set alarm button. You hear that? This is, oops. Okay, let's disalarm it first. Now we've got this thing as the set alarm signal. I haven't set it to a variable. Let's do it again. Right, it's true. Okay, it's the same process. You can see the hex format is like this, and if you set it this is set alarm. Well, just make it easier, right? And then we will use a, oh, I forgot what was it. Okay, I don't really care about that. And then we can use what was the command here? Okay, ser1.write and bytes.from hex signal of set. Oops. Try again. This thing is really bad. Here, yeah, you can see that. It's already set to sound alarm when it sees me. Okay, now let's disalarm. Okay, this is the basic idea behind reading and copying and setting the radio frequency signal to control all these dumb radio frequency maybe alarms or switches, maybe a garage door, whatever that has a remote control. And I can show you the program I wrote. In this program, this is the program I wrote. It can be run from the command line. It's actually fairly simple. So I have this radio frequency object, serial object, and then it has a listen function to keep listening and decoding the control signal, and we have this send function. You can give it a signal with a string format, and it will be if you call this function with a string, it will send the signal to broadcast the signal. And of course, we have this port close to ensure that your serial port is closed elegantly when the program exits, and have this helper function of nice print that will turn this this very long byte string to a 8 bytes. And then I have this main function to start listening or to start sending the signal. So this is how this radio frequency signal is gonna work on the Chipsee all-in-one Raspberry Pi computer together with this adapter. So that's it for this simple hacking of a dumb alarm. Maybe you can set your alarm to turn on every night or every morning when you leave home. Next time I will show you how the same technique can be used to a dumb switch. I will be able to use that to control my air purifier or some other things that you want to be able to control, which is dumb, but you want to set a schedule to turn it on or turn it off. So see you next time.